This is a review of Algebra 1 to get you ready for what we're going to talk about in Algebra 2 pre-AP. So let's talk about slope. Slope is known as the slant or steepness of a line. It's also known as a rate of change, or more specifically, it tells us how y changes with respect to x. So we can say delta y over delta x. And remember in science that delta means change. So it's change in y over change in x. So if I have a line that goes from left to right uphill, we say that this line has a positive slope. If I have a line that goes downhill from left to right, wherever it is on the graph, we would say that this line has a negative slope. And the way we calculate slope, which we abbreviate with an m, is y2 minus y1 over x2 minus x1. It doesn't matter which y we call y2 and which one we call y1. The reason we use those subscripts is that we remember the points go in the same order. So if I start the calculation with one of the points for y, I have to start it with that point for x as well. And I'll show you what that looks like. So slope is just going to tell us rate of change, change in y over change in x, or it measures the steepness of a line. So the larger the slope, the steeper the line. So if we look at an example here, we've got, let's erase these real quick and let me show you an example. We could have two lines. So I could have this line right here, and I could have this line right here. This line, line 1, is steeper than line 2. So the slope of line 1 would be greater than the slope of line 2. The larger the slope, the steeper the line. And that works regardless of whether we're talking about positive or negative. So ignoring the sign, so we could maybe say the absolute value of the slope. The larger the absolute value of the slope, the steeper the line. Something else we need to talk about is lines that are flat, so they're not slanted at all. So if I have a line, for example, that looks like this, we would say that that line has no slant or no steepness. There is no change in y as my x change. So as I go from one x to the next, the y does not change at all. So we would say this line has a slope of 0. However, if I have a line that's straight vertical, that means y is changing. The x's are staying the same, but y is changing for everywhere on this line. For this, we have really no definition. There's no number that defines the steepness. So if I want a line that's perpendicular to 3x plus 2y equals 10, then that means I need to find the slope of this line. Well, we just did that on the last slide. We got y alone. So 2y was equal to 10 minus 3x, and we divided by 2, so y is 5 minus 3 halves x. So even though I've written it out of order here, the slope is always what's attached to my x. So my slope is negative 3 halves. So if I want a perpendicular slope, and the little upside down t means perpendicular, I take the opposite, so instead of negative it will be positive, and I take the reciprocal, so that would be 2/3. And I can graph the line now that goes through the point -2 up to 7, so I'll kind of draw that point up there, and has a slope of 2/3. Now this point is off my graph already, so if I go up 2 and over 3, that's even more off my graph. So I can go down 2 and left 3. So that's like saying -2 over -3, because a negative divided by a negative is a positive. So down 2, left 3 gives me this point right here. Down 2, left 3, I'm off the graph again. So here would be my line. And this line would be perpendicular to the line that I've figured out right here, meaning when they cross, they would cross at right angles. So two equations can be parallel, they have the same slope and they'll never touch. They can be perpendicular, meaning they will cross at exactly right angles, or they could cross but at something other than a right angle, so they're neither parallel nor perpendicular. All right, so let's take a moment to talk about x and y intercepts. An x-intercept is the place the graph crosses the x-axis. We talked about this the first day of school. So it's where the graph crosses the x-axis. Math people are not creative. That's why we called it the x-intercept. It is also the x value, since it's the x-intercept, when y is equal to 0. So if I cross the x-axis at this point right here, then that point is 4, 0. It is the x value, and y is 0. He is the x-intercept. The y-intercept is where the graph crosses the y-axis. And algebraically, it is the y value, since it is the y-intercept when x is 0. So to find that, I'll always have an x of 0, and I'll find the y. So for example, I could have this point right here. So this is my point 0, 4, and he is the y-intercept. And this is my point 4, 0, and he is the x-intercept. So we can actually take a look at a situation like this. We can have the x-intercept of negative 4, 0 and the y-intercept of 0, 3, and we can go ahead and graph a line given 2 points. All I need to graph a line is a slope and a point, or 2 points. In this case, I have the point negative 4, 0, that would be my x-intercept, and I have the point 0, 3, that would be my y-intercept. Now all I need is a straight edge, and I've got the graph of a line. From here, I could also count my slope. If I start at the left-hand point, I would go up 1, 2, 3, and over 1, 2, 3, 4. So up 3 over 4 is a slope of 3/4. Once I know that, I could plot other points. So from the second point, I could count up 1, 2, 3. I could count up 1, 2, 3 over 1, 2, 3, 4. And I could go down 1, 2, 3, left 1, 2, 3, 4, and kind of be off my graph. And now I've got a line, and all I needed to know to draw it was the x-intercept and the y-intercept. And I even know the slope of that line. All right, let's take a look at y equals mx plus b. I know you remember y equals mx plus b. This is the equation called the slope let me take that little guy off. Let's write in something we can read. This is the slope-intercept form of a line. Now again, math people, not super creative. So where in the world did we get this name, slope-intercept? It's because we are using the slope, m, and b is the y-intercept to graph a line. So if I get a line in y equals mx plus b form, I know the slope and I know the y-intercept. All I have to do to graph it is graph the y-intercept and use the slope to count, and I've got the equation of a line, and I've also got the graph of a line. Now, I can write it as y equals mx plus b or y equals b plus mx. It does not matter. The slope is always what's attached to the x, and the sign of the slope, the sign in front of the number, goes with it. So let's take a look at an example in your notes. We are going to write y equals mx plus b equation if we're given a slope and a y-intercept. So I know the slope is 0.25 and the y-intercept is 4. So y equals m, that's my slope, 0.25 x, plus my y-intercept, so plus my y-intercept of 4. This is the equation of the line in slope-intercept form. This is the same as y equals 4 plus 0.25x. They are interchangeable. If I wanted to graph this, all I need is one point and the slope. So my one point is 0, 4, and then my slope is 0.25. 0.25 is the same as 1 over 4. So I could go up 1 over 1, 2, 3, 4, or I could go down 1, left 1, 2, 3, 4, and now I've got the graph of this line. Now, we're not always given the slope and the y-intercept only. Sometimes I'm given other information. So I could be given a y-intercept and a point. So let's say you were given a y-intercept and a point, and you wanted to be able to graph the line. Well, obviously, all I need is 2 points to graph the line. So over 2, up 0, and left 3 down to negative 11. Now that happens to be off of my graph. All right, so I've modified this a little. Let's see if we can do this now. So I've got the y-intercept of 2, that's an x-intercept. Let's do this. Let's say we have the y-intercept of 0, 2. So over 0 and up 2. And then I've got the point negative 3 up to 11. So there's 8. I could kind of estimate 9, 10, 11. And then I could figure out, if I had a ruler, the equation or the graph of the line that goes through those 2 points. Now, I can also write the equation for the line that goes through those 2 points. And so we're going to say y-intercept of 0, 2. That was a typo on my part. Well, if I need to find y equals mx plus b, I know the y-intercept. I've got that. He's 2, so b is 2. All I need now is the slope. If I've got 2 points, I can calculate the slope. So y2 minus y1 over x2 minus x1. And I've got 9 over negative 3 or negative 3. So my equation would be y equals negative 3x plus 2. So it would have a slope of negative 3, and it would go through the point 0, 2 on my graph. Or we could write this as y equals 2 minus 3x. We could say 2 plus a negative 3x, but plus and negative is fairly redundant. So we just write 2 minus 3x. These are the same because in both of these equations, 2 is positive and 3x is negative. Let's take a look now at an example that has fractions. If I have an example that has fractions, like the slope is negative 1/4 and the point is negative 1, 3. So let's take a look. We wanted to write the equation y equals mx plus b. So far I know y equals negative 1/4 x plus b. Ooh, the only problem now is I have a point that's not the y-intercept. And I need to know the y-intercept for the equation of this line. So this is probably the hardest question we've looked at. How in the world would I do this? If only I looked at that equation, I have an x, a y, and a b. In order to solve an equation, and I need to know b in this case, so in order to solve for b, I need to plug in something for y and plug in something for x. Here's our lucky day. We have a point. Our point is always an x, y point. So y is 3 in this case, and x is negative 1. And I can solve this equation for b. So negative 1/4 times negative 1 is positive 1/4 plus b. If I want to get b alone, I need to subtract 1/4 from each side. So if I come up here and rewrite my equation, if I subtract 1/4 from the right, I have to subtract 1/4 from the left. Bring down my equal sign, and b would be equal to 3 minus 1/4. Well, in order to subtract, these two fractions have to have a common denominator. So on the left, that 3 over 1, I'd have to multiply the bottom by 4 and the top by 4. So I end up with 12/4 minus 1/4, which is 11/4 for b. So now I know my y-intercept and I know my slope. I can write the equation of the line in slope-intercept form. So my equation for my line in y equals mx plus b, or slope-intercept form, is y equals the slope, negative 1/4, times x, plus my y-intercept, 11/4. Or again, we could write this as 11/4 minus 1/4 x. Either form is perfectly acceptable for slope-intercept form. All right, so I've got to figure out a way to figure out whether or not you watched this video, and hopefully you've learned something today or reviewed what you already knew. If you have any questions about this video, please come to tutoring immediately. I want to make sure you understand all of this material before we go on to new material for Algebra 2. This was a very quick 13 or so minute review of what you learned in Algebra 1. Now, how in the world am I going to know whether you watched this video when you come and ask me questions? Well, you have to be able to answer the following question. The secret question is, who is Mrs. Cornett's favorite college basketball team? We all know I'm a huge Spurs fan, but I do love basketball, and so I have a favorite college basketball team as well. And that team would be the University of Kentucky Wildcats. Go Cats! So come and see me if you have any questions, and I will see you soon.